an interesting summation problem here. Have a go at it first. First n terms of this series here. What's the sum? Find it out. Otherwise, keep watching. Let's do this. So we've got lots of odd numbers on the bottom, which is kind of interesting. We're always getting this. The first one always increases by 2, obviously, and just goes to the next odd number. The second one is 4 greater than the first one was, and also increases by 2 every time. So I think I can write this in a formula like this, right? Where I've got an odd number here, which is going to be representing the 1, the 3, and the 5. And then another odd number here, which is always 4 greater than this one. And if I start with n equals 0 as the first thing to plug in, then I'll get here 1 and here 5, and so that gives me this, and then the next term would be n equals 1, and I get 3 here and 7 here, so that gives me that, and so I'm happy with this. And remember, the question is asking you for the first n terms of this. So it's really tempting to go up to n here, but actually you only want to go up to n minus 1, because you're starting at 0. So when you consider 0 to be an actual number that you start counting from, when you count n places forward, you actually only arrive at n minus 1 once you finish counting. Kind of cool. That's the mistake that I made when I first saw this question. Just lazily went to n, but it's actually n minus 1. Okay, so how do we deal with this thing here? Because there's definitely no formula for reciprocals of things like this. Well, what we can do is we can just do some partial fractions. That seems like a very natural thing to do to this. There's a product on the bottom, so let's try and break that up into 2 fractions then. So of course, timesing this one by 2n plus 5 top and bottom, and this one by 2n plus 1 top and bottom, and then just reading from the numerators, we get 1 is equal to a times 2n plus 5 plus b times 2n plus 1. Then just comparing the n's, there are 2a plus 2b n's on the right and 0 n's on the left, so we get this. Comparing the constants, we have 5a plus b equals 1. This is just a similar to this equation. Double this one up, put this one underneath it, take away, divide by 8, and we get a as a quarter. This one clearly says that b needs to be pretty symmetrical with a, so b is going to be minus a quarter. Put those two values into here and replace this with those. And now, of course, we can just factorize out a quarter from both of these two things, because sums don't care about constants. So I'll put the quarter out here and deal with this thing here. And now how do I deal with this? Because there's still no formula for reciprocals like this. Well, what we can notice is if we just write out the first few terms here. So this one is going to be 1 over, when n is 0, you get 1 over 1. When n is 1, you get 1 over 3, then 1 over 5, then 1 over 7, and so on. And I'll have a quarter of those things, all the way up to 1 over 2n minus 1. Because when you put in n minus 1 into here, you get 2, lots of n minus 1, which is 2n minus 2, plus 1, 2n minus 1. So that's going to be the last term. And then I'm going to take away, and again distribute the quarter, take away a quarter of all of these inputs. Of course, when I start with n is 0, I get 1 over 5, then I'll get 1 over 7, then 1 over 9, and so on. So take away a quarter of those. But what we can see now is that all of these terms, from here all the way to here, and I should say the last two terms are going to be these two. There shouldn't really be 2 pluses there, but whatever. Because when you put in n minus 1 into here, you get 2n minus 2 plus 5 is 2n plus 3. So okay, well, all of these terms are going to cancel with all of those terms, and all we're going to be left with is a quarter of these two things minus a quarter of those two things. And this should be very easy for us to deal with. This is 4/3. We can start putting those fractions together in normal fraction ways, I guess. Put these together for 4n plus 4. The 4's cancel here for a third, and then divide this by 4 to get n plus 1, and this will be our solution. Kind of an interesting question. It also is quite nice that because you've got an n squared term on the bottom here, if you send n to infinity and say what's the sum of the first infinite terms, I guess, this sum will eventually just go to 3, because as n goes to infinity, you've got an n squared term on the bottom here, so this will just go to 0, and you'll just end up with a third, which is kind of interesting that this sum limits to that. Anyway, yeah, thank you to the person who sent that in. Quite a nice question.